Hello, today we're going to be tackling an improper integral question. The question, which you can see on your screen, is as follows. Integrate between 0 and infinity 1 over, all in brackets, 1 plus 2x, close bracket, squared. To begin, you should draw a graph, so you know where the equation is above the axis and where it is below, and where any asymptotes are. So here we've got the equation of y equals 1 over, all in brackets, 1 plus 2x, and that's squared. So to start off with, we need to find out where y is undefined. So y is going to be undefined when the denominator of the equation is equal to 0. So here we've got 1 plus 2x squared is equal to 0. Using some simple rearrangement, we can get 2x is equal to minus 1, and therefore x is equal to minus 1/2. Let's put this on the graph. There we go, minus 1/2. And that's where there is no value defined for y. So when x is equal to 0, we can plug 0 into the equation, and we get y is equal to 1 over 1 plus 0, all squared, which evaluates to y is equal to 1 over 1, which of course is equal to 1. Plotting this on the graph once again, and there we go. So the next thing we need to do is evaluate the equation for when x is close to infinity. As you can see, when x is close to infinity, the denominator of the equation is going to be very, very big, so therefore y is going to equal 0, or tend to 0. Similarly, when x tends to negative infinity, y is also going to tend to 0. So one last thing before we draw our graph is, because the graph is in the form 1 over a squared, we know that it must look like the following. So now drawing the graph onto the equation, we've got it starting at a very, very small when error x is very, very big, passing through 1, and going up to that asymptote of minus 1/2. And there's the other half of the graph, so when x tends to negative infinity, we've got y is very, very small, and as x approaches minus 1/2 from the negative side, y tends to infinity at that asymptote at minus 1/2. Now that we've drawn our graph and we've plotted what part of the graph we need to find the area of, which is highlighted here in black on the graph on the screen, we need to start calculating and evaluating the equation. So first things first, we've got to replace the infinity sign in the integral with a limit. So first we write the limit as t, which is just an example variable, tends to infinity, of the integral between 0 and t, of 1 over, all in brackets, 1 plus 2x squared with respect to x. Next, we need to integrate the equation. I've just gone straight from one step to the next and haven't gone through this subsequent intermediate steps in this case, but if you look at some other videos, you'll be able to see how to do the integration of this type of equation. So we start off by writing once again our limit as t tends to infinity, and then we've got the integral, which evaluates to 1 over 2, and then in brackets 1 plus 2x, and closing the bracket, and of course our limits 0 and t. Evaluating the equation with our limits, we've got the limit as t tends to infinity of minus 1 over 2, and then in brackets 1 plus 2t, close the bracket, take away the negative of 1 over 2, open bracket, 1 plus 0, as we replaced x with 0. As t tends to infinity, the equation of 1 minus 1 over 2, and then in brackets 1 plus 2t, tends to 0. So in the next part we can remove that part of the equation. Therefore, 0, take away the negative of 1/2 is of course equal to positive 1/2. So summarising, we've got the integral of 0 and infinity, between 0 and infinity, of 1 over 1 plus 2x all squared with respect to x is equal to positive 1/2. Thank you very much for watching. I hope you learnt something from this video. Please take your time to look at the other videos. Like this video if you found it useful. Leave a comment if there was something you don't understand. And